Hey, Fitzy here, back at it again with another one. Many have asked about MIG wire. What size wire do you use? Can you use flux core wire? Well, today we're going to find out about the flux core. I have different size wire that I'm going to use with gas, and I have a roll of flux core wire that I'm going to experiment with and see if I can do a cotton butt with. Guess what? Tony can make a mess too. Stick around. Okay, so here I got 4 different styles and sizes of wires, okay? What we got here first, this is the one I use the most, is 0.023 or 6 millimeter, and I use a gas with this wire here. Over here now, I have a roll of 030, 8 millimeter, and that's also gas. Now, the difference between the two of these is this is a thicker wire than this here. That's basically the only difference in the two of them. And I'll show you the difference in the two of them when I go to weld. Now over here I have the same size wire as this one, but this is in a shielding gas or flux core, 030, 0.8 millimeters, and it's a flux core wire. This is the one that you run without gas, okay? This is the one that a lot of you are using, and I find that I'm going to do an experiment today just to find out how this compares to what I use here, more or less. And I also got a thicker wire again, which is a flux core, 0.035, 0.9 millimeters, and it's a flux core. It's a really heavy wire itself. So I'm going to see if I can put this one on my machine. Now, in order to change these two here, and also with this one here, you're going to have to put the proper tips in them. I got the 030 tips, 6 millimeter tips, and then these two here, I got the 030 tips with the 8 millimeter tips, and then over here I got the 035 tips. So you got to change all them on your welder in order to work on them. Now the welder I'm using is my little Millermatic 140 auto set. It's a good welder. It's much the same as the older 130s. This is a newer model of it. This one here got more settings and everything on it. I have this set up here now, roughly about where I would use the 030, welding probably 18 gauge. As you can see here, this says 18 up here, but I got it down here in the 20 gauge. This is a lot of the cases of using the thinner metals and whatever. The settings are all according to what you can use, okay? But I'm going to use this welder for all these applications and see what I can come up with. Okay, the gas I'll be using with the shielding gas is going to be CO2, carbon dioxide. Now, a lot of people have been talking and saying they can't just get the CO2. All they can get is like a CO2 argon mix. Can you use it? Yes, it is a better gas than this here. The reason why I use this is because I use it for bodywork only. And you're going to be grinding all your welds down. The argon mix gives you a cleaner weld. You get less splatter, that type of stuff with it. It's just that I find that having that gas is a lot more, it's more costly for me to run it when all I'm doing is body work. So, you know, you can use either the CO2 or the CO2 argon mix, either or, whichever one you like. So you can see that there is only on 12, right? That tells you how much gas is in your bottle. But I usually set that on 12, and then when you hit the trigger, it'll come down to about 11. You don't need no more than that. You got the wire feed set up there with your wheel. Your wheels will have to be changed, okay, from the different size wheels. This one here is a nice little, quick disconnect on this one, as you can see here. And basically, whatever side that you have facing out, see that was 024 6 millimeter, and then you turn it over. That'll be the side that faces out, but it's marked on the opposite side. So this side here is for that side over there. Some of these you'll have down both these. This is a newer machine, so this is all you got to set up at, and it just snaps right on there, like so. Now a lot of the machines have these little charts that are on your welders on the inside of the door, as you can see here, that you can actually get a baseline of where to start from. It's a good reference point to get yourself started. But don't look at it and say this is cut in stone, so this is exactly what my setup should be when I use a certain size wire or a certain gas or whatnot, because it's a ballpark figure. It'll get you started. So you use this information on these charts here, O2 wire, and then you got your gauge of metal, and it'll tell you 2 to 4, right? So this is where it comes from up here on this unit here, which is out front here, right? It'll say like 2, and then it'll be 4 up here, see? Now, as you can see, my settings are totally different, right? Because I played around with it and got one that I like better. A lot of times, these are not as close as they should be. I just find that they're a good reference point for when you first get started. Start here and then play with it from there. Okay, now most welding how-to videos, you'll always find guys how to set up your welder and how to weld and how to butt weld and all this type of stuff. And they're always doing it with this type of metal. Okay, this is a piece of 1/8 or 3.2 millimeter steel. It's a thicker piece of steel. It's very easy to weld. Fellas, you know, do a lot of welding videos on these and heavier plate and stuff like that. And I find it's very hard to find anything around when it comes to sheet metal. Welding this is not the same as welding automotive sheet metal. It's not the same process. Showing how to weld by using this here, and you're going to weld up quarter panels on your car, well, that's, to me, that's not a really good explanation. Now, up here I got 3 different style metals, okay? This is big heavy 14 gauge. I've used this in some of my videos for making mounts and stuff like that. It's a heavier gauge, 2.8 millimeters thick. The most common one I use is this one here. It's an 18 gauge, 1.2 millimeters. This is the most common steel. I like using this even when I'm running slider metals like that over there, because it gives you something, more strength to it. And when you're doing a lot of grinding and stuff like that, if you concentrate on this here, if you start with the 18 gauge and start grinding it down, you'll grind it down to 19 or 20 or something like that when you're finished grinding down. So you got room to grind the metal down to finish it at the end. Now over here, this is the most common metal you're going to find in a lot of modern day vehicles. It's 22 gauge, 0.08 millimeters. Now this is the stuff that a lot of you guys I've seen are welding up. So what I'm going to do today, I'm going to do all my welding on this piece of metal here. This stuff here is a lot easier to work with, okay? This here is not as easy to work with. So when I start putting all the heavier gauge wires and the flux core wires into this here, you're going to see a difference in it. So I'm going to cut individual pieces out of this here, and I'm going to do a butt weld on all of them, and I'll show you that. But this is the metal we're going to use. It's just a regular automotive car. This is a roof off a Ranger pickup that I saved. So it is an actual car roof, actual steel that come off a car, because look, there's the sealer from the roof on it. So I'm going to cut a bunch of strips out of that and get started on it. Now, to get a better understanding of the gauges, you can see here the thickness markers: 20 gauge, 22 gauge, 24 gauge, 16, 14, 1/8, whatnot. You can see actually how thick the actual metal is. So this will give you some idea of the different metals. Now we're at the second last one up here, 22 gauge. There are cars out there now today with 24 gauge on them, and it's extremely hard to weld, but for the most part we're going to go with 22 on this one today. As you can see, 18 gauge is what I usually weld at. So let's get started now. Now for each one of these tests, I got little strips of metal cut out. It's the 22 gauge, it's all going to be the same way. I clean up the metal both sides, right? I just cleaned it up with a 24 grit disc on my air grinder. I'm going to clamp them, and I'm going to do a butt weld down through here on all these here. On each panel, I'm going to butt weld one, and I'm going to go through the process of what it's like to weld and whatnot. So what I'm going to start off with is what I'm always using is the 23 gauge wire, or sorry, the 023 wire, 6 millimeter. And I'm going to go through the process of welding this up. Now, I always spot weld. When it comes to welding automotive panels, the one thing you see when fellas teach you how to weld videos online when they're welding the heavier steel is the boys are running beads. Don't go running beads on sheet metal, okay? Especially this 22. I'm going to show you what happens, because I'll actually run a bead on another piece here in a sec. But all you do is you do spot welds, right? Have them about 1 inch apart, and then off them one at a time after another, and work on basically getting the panel up and cooling it down. The key to it is to keep the panel cold. If you get any amount of heat in this thin metal, you're going to warp the dead out of it. Now, when you're welding with the gas, you got your tip, which in this case here is a 023 tip. Make sure that your wire's only sticking out a small bit from it. But these nozzles on this machine here got a tendency to drop back on the back side, so when you push them on, the tip sticks out. By rights, you should have the tip submerged below the end of the nozzle. So make sure that you haven't got this type of thing going on. You'll find it doesn't get the shielding gas as good, so you got to have a little bit of protection like that over the nozzle in order to get the gas. So you may have to adjust it a small bit or replace it. When you get the new one, you'll see this round sleeve on the bottom here. This will be more to the bottom, but I've after cleaning it that many times now, is after sliding down, putting it on, taking it off, right? So I just has to keep an eye on it. I puts it on and I just pulls it up a small bit. All I'm going to do here is I'm going to hold it in place here on the end and put a tack weld down it. And then put one every inch or so. I like cooling it with air. Some say put a damp rag on it, but you're going to have to weld this and you'll contaminate the metal where you're welding it if it's wet. So it's best to do it with air. Be very patient with it, because if there's still heat in the panel, there's a greater chance you're going to warp it all up, okay? So now I'm going to go in now, and all I'm going to do is I'm going to start tack welding next to these here and work my way across to each one. And each time I tack weld it, I'll cool it. It's a long process, but it pays off, and I'll show you why. The new wire. I'm sticking to a small area there, so I'm going to stop it there. And there's all I got done, as I got them welded next to each other and I gapped them out and done them apart that way. Okay, so now that weld is done there, and you can see I'm getting a decent weld on that there. It was easy to weld the small stuff. I had a bit of trouble at first, but I adjusted my welder, and so I turned around and I welded it. Now over here, my settings on my welder, I have a high wire speed of about 70. I like it up there, and then down here I got it set up on between 2 and 3 on 22 gauge or on 20 gauge, and it's halfway down there. I like that setting there. I like my wire speed here. I like having a bit of wire speed. So that's the setting I use for this. Now you can't go by this setting on a different welder. Okay, this is something you've got to play. I have a video on setting up welders, so it's best to go back and look at that one and find out the best way. For this welder here, for me, doing this metal here, this is where my settings will be. All welded up on the inside. Okay, and you can see that's the inside and there's the outside. So you're getting good penetration. It's just spot welds, and this is what you're after, is to get this penetration. You can see I had a bit of trouble up here. I burned through, and there's a bit of knob wire and everything. That's fine. Now when you lay that down there, you can see there's a little bit of warpage on it. Oh, there's wire in the way. I had to grind that off straight. But anyway, you can see the little bit of warpage just on that there. That's because it's small. Now, that there, I can get that out because these small panels. But what I'm going to do is I'm going to go over and I'm going to take 2 more pieces now, and I'm going to tack 3 spots on it. I'm going to run beads on it. And I'm going to show you what happens when you put too much heat in the panel. Okay, same process as before. Just going to tack weld the 2 panels together. And this stuff is staying the weld, I can tell you that. got the 3 of them tack welded in place. And I'm just going to leave that panel. Just look at this there now. Not going to do nothing with it. I'm going to start running beads now. Now right off the bat, you start blowing through because your heat settings are so high. So you have to turn your welder down in order to keep running beads, and that way I find you probably won't get as much penetration. I'll just keep going with it. You see I'm starting to run into problems again because I haven't got to let it cool down. So I've got to play around, turn my welder way down in order to get this to run a bead. I like working with a lot of heat. Now I got it so I can actually weld it, okay? Don't like the wire speed on that. Turn that down a bit. And I'm still burning through it because I got everything fooled up here. Turn it down some more. Now it's constantly running into problems with burning holes in it, as you can see, trying to run a bead. I never cooled it, I just kept going. You can see the heat transfer I got going on here now, how much is there compared to this one here. See the heat transfer? There's not as much heat transfer on that there as what is on this here. Now the problem you run into, when you turn it over, you're not getting a consistent weld, okay? I'm running into a lot of problems. Look at the problems I'm running into. Look at the warpage I got going on here. A lot of craziness going on. This is what ends up happening when you start running beads. Like, that's still hot. And there's way too much heat in there because of that. This is what you gotta see. Like, you can actually look at a guy with his welding in a rig and you can see how much this here, there's not a lot of heat in here. Okay? There's a lot of heat in here. This here is trouble because you'll end up warping everything up on your panel. It'll separate. You notice I put a spot weld here, but it's still separated on me. Look. And it looks messy, as you can see, and you compare it to that there. Right? So that's one thing to understand when you're MIG welding sheet metal is the control of the heat. Running a nice bead, like I can just turn around and sit down here and run a real nice bead on this here now, and I'm going to warp the dead out of it. Because that's one thing people looks at when they see is this type of bubblegum welding, if you want to call it, or small spot welds like this here. It doesn't look pretty. You're doing body work, it does not matter because you're going to grind all this off anyway. There's your key there. Look. Make sure you got good penetration and your panels stay together. Okay, these are small panels and there's a small bit of warpage in this, but that's because it's such a small panel. But there's a lot more warpage in this if you look at it than what was on the other one. See how bad that one is compared to this one here. Okay. Now I got this piece of 14 gauge here now. What I'm going to do is I'm going to run a bead of each type of wire on here so we can compare them later on and see what the differences are in them. This is the 023 wire. So there you have the 023 wire. Now I'm going to go up and I'm going to step up and go up to the 03 wire, which is, as this is for gas as well. And we're going to go through the same process again. I'm going to change the machine over for this wire here. And we're going to try this, the same process, same techniques, and see what it looks like. Okay, so I took the large roll of 023 off, which is 6mm. And I got to put on the larger roll, or the small roll of 030, sorry, get that straight away. Now the problem you got is this here. This is a small roll, so it takes a small section on it. This here has an adapter on it for taking the larger roll, so I got to remove this adapter in order to change it over to the small wheel. Now the larger wheels are just held on with like an outfit like that. Sometimes there's a pin in them, so you just remove all that. You don't really have to remove all that, but and you just take off this inner one here. Pull all that off. onto the washer. And you slide that on, and you put the spring, the washer and everything back on it again, like so. Now that I got the wire in place, before I run it through, I got to change over the wheel on it because this is set up for 023 wire. You can see it's a smaller wheel on it, and it's set up for that there. So I had to turn it around and reinstall it so the wheel will be on the larger side. Now that's ready for the larger wire. I'll just feed the wire through it. Okay, the other thing you got to do is change out the tip. This is the 023 tip here. I got to take that out, and I got to put in an 030 tip. So I got that changed over with the new wire now. I can put the nozzle on it and I can start welding. Okay, I played around with the welder, playing around with the settings on the welder because there's different wire size till I got to a heat range setting, or basically that I was laying down a nice pass, right? And now this one's different now because I had to lower my wire speed down to about 45, and I had to turn up my heat setting to 18 gauge. Now the problem with it is when I turn that down to weld a slighter gauge, I wonder if it's going to work right. But I just did this for a rough test of it now. So I'm going to try to see what it's like for welding the 22 gauge there. So this is a thicker wire, and because it's a thicker wire, it's going to need more heat, like it just showed on the settings. But at the wire speed, I turn it down. So I'm going to see what happens now when I put a tack on this to see if them settings are going to let me weld it together. Right off the bat, I'm just blowing holes in it. So I got to turn it down. Try it again. You see the troubles I'm having now trying to get this to weld. Trying to get it to weld here. A little bit more heat. And get it here. See, it blows through very easy. It's a thicker wire. It's a lot more heat. So I'm going to run into a lot more troubles trying to weld this. I turn the heat up to get a better penetration. That's pretty good back there. But as you can see now, I got a larger wire in it, and what's happening, it's harder to control the heat. In the thinner metals, you start blowing through holes. Another little feature that I know on this here, if you notice, is that my welds are bigger, right? And because the welds are bigger, there's more grinding involved in it. Because I got to add more heat to it in order to get this to burn. But when I add more heat to it, it got a tendency to want to burn through. So like you got the smaller wire, which is the 023, and this is the 030. It's not a big difference in the wire sizes, but there's a big difference because this here now, you get welded with it. It's tricky because it's a larger wire. So, but you got a lot of grinding on it because of the larger wire. Now, this is the 023 wire right here. That we went and welded there, and this is the 030 wire. Okay, now you look at that, that looks like a nice weld. Okay, and then you look at that there and you don't think much of that weld here. Now I turn this over, there's our penetration there. Turn this over, there's our penetration there. We're not getting full penetration on it because I'm trying to reduce the heat to get it to weld so I don't blow through. You can probably play around with it and probably get that there a bit better than that. But you can just tell by just looking at that and looking at that, the difference in the two welds. It's a lot harder to do that, and you can see the heat transfer on that there, moving out. And the same, and this one here. Now I never cooled this one like I cooled that one there, so that would play a part. These last few here, but even on the very top up here, if you just look at this very first one that I hit, and this very first one I hit here, this here is a colder weld than this one. But the penetration on this is not that good, and you'd have a lot of grinding to do, and you'll end up grinding through it. So the thinner wire does wonders, as you can see there. Look. There's way better penetration here than there is here. Now I got the 023 here, so now I'm going to run it this here. I'm going to always run it the same way. I'm not going to change the angle up because it'll change the layout of the welds. You can change it and weld it this way or weld it this way, but I'm going to run it each bead the same way. Now this is 14 gauge metal, but I'm welding this here with the setting that I used on the slider gauge that I can try to weld it with. So like I could turn it down or turn it up a bit, make it hotter to burn this metal. But I'm looking to lay this to weld down at the setting that I set it up at. Now the setting that I have this one set up on, I have it here, just on 3, and it's on 45. I lowered the wire speed down here because I had to lower the wire speed down because of the thickness of it. It burns hotter, so I got to slow the wire down. And the gauge is roughly in the same location as the other one. The other one was about right here when I was welding the 023 wire, and I just moved it up to here. I played around with it a bit, and that's basically the setting that I got. So I went ahead and I welded it in here, and already you can see there's a big difference in the two welds. This is a thicker wire, that's a thinner wire. So when you look at it, when you size them up this way, you can see you would have a lot of grinding to do. All right, now it's time to move on to the flux core. Okay, so now I just took the roll of 030 or 0.8 millimeter steel wire out, and now I'm putting the flux core in it, and this is the difference in it. This here has a core in the middle of it with flux in it, in the middle of the actual wire itself. So this is the stuff that a lot of you guys are welding with. When you buy a cheap little welder and it doesn't come with gas, this is the wire you would run. This is the stuff that you'll be able to do out by the door. You got no issues with it. This stuff is used a lot in outdoor welding. A lot of welders do like it, but what I mean by welders, these are guys that are doing a lot of structural work. These are great. This wire is great for welding heavy plate steel and stuff like that. It's a really good product for that. But when it comes to auto body, it's a totally different game altogether. So, like, I've never used this right from day one. This is my first experiment with this here now, so I'm going to play around with this. I'm going to put this in the machine, and I'm going to play around with it for a while before I even try to do any tests on it, just so I can get a feel for the stuff. I've been at this 30 years, and right from the get-go, I started using wire with gas. It was told to me that's what I had to use for auto body, okay? This stuff here was something that welders used to use, but like when I got into it, the small MIG welder wasn't very popular, so it was still big MIG, so it wasn't like there was a lot of fellas around that had the small welders. But when the small welders got popular, a lot more people start using this wire and trying to do body work with it. And like if you're a first-time welder and you're just starting into body work and you're using this stuff, don't let it frustrate you, and because it is not a very good wire for welding bodywork. There's guys out there that got the knack of it figured out. They've been at it for a number of years. It's probably better to do lap welds with it than it is to actually try to do a butt weld with it. But I'm going to do a whole bunch of experiments here now. I'm going to play around with it and see what I can come up with. But I'm going to put it in the machine, and I got to change one thing on the machine. So I'm going to get this installed first, and then we'll set the machine up for it. One thing to remember when you're putting on a new roll of wire is to turn around and adjust this tension here. That's what that spring is for. Don't have it too tight that it won't spin freely, but make it tight enough that when you're running the wire through, that this don't keep spinning when you stop the trigger. So just play around with it until you get the tension right on it. Now, here's where it comes in. We're using flux core wire now, so we have to change the polarity right here. What this is, right here you got your work clamp, okay? and then you got your wire drive lead. This is your power source here, and then this is your ground wire. So if you look at here's your ground, okay? Ground wire. That's your ground wire. We had to reverse this here. This goes into the machine here, and it comes up through here, and it goes to here. What we got to do is we got to put this one here on this lug, and then put this one on this lug. It's a simple process. You reverse the polarity on this here to change them around. This is your power source, and this is your ground. So just reverse the two of these here for flux core wire. That's all I went and did. I got my ground on my positive side, and I got the power source on the ground side. Now, before you go at that, do not forget, unplug the machine. Don't go doing this with the machine plugged in. So make sure you got that unplugged when you're doing that. So now the welder's set up for flux core wire. Now when I goes back to solid wire and I start using gas, again, I'll have to change these around again. I'm not going to do nothing with the machine here. I'm going to leave all this, going to leave the bottle turned off. I'm not going to bother with none of that. I'm going to leave the tips and everything alone. I'm just going to go ahead now and start trying this and see what it's like. Now, I've played around with the welder some, and I come up with these settings here. I'm down around 2 on the gauge lead meter and the material thickness. And I'm just a little above 40 up here, playing around with the wire speed. I did a bunch of test passes. I have a bunch of old scrap pieces here I played around with. I played around with doing some tests on. Just trying to get a feel for using the stuff. It's different. It's my first time using the stuff. I got the pieces set up here. Now I will say one thing. A lot of you have watched me and caught me in a few of my videos welding without a helmet. It's not a good thing. Shouldn't be at it. But I noticed something here going with this flux. You cannot do it without a helmet. The flux is a lot brighter. There's a bigger arc and everything on it. So, you know, you're not doing this the way I does it with the gas welding. I can hide the arc behind the tip of the gun and there's not much of a flash. Like in terms of there's not much light coming out. I've been doing it that way for years, just being quick, doing body work. It's not a way they should do it. You should always wear a helmet. I say that again and again and again. But everybody keep asking me about it. All I do is I hide the arc behind the tip of the gun. But with this flux core, forget it. You'll never do it. I'm here and I tried it, one arc, and I said, nope, won't be at that. So then I've gone back and I had to wear a helmet and everything like that. I played around with it. It's different to use. It has its, what do you want to say? It has its pros and has its cons. It's really cheap, cheaper to use. Right now I haven't really found no cons to it other than the heat range is trying to get it low enough that I can weld the thin stuff. So I'm going to go ahead, I'm going to do a few patches on this here and try to join together a few beads and see what it comes out like. Now I played around with cleaning the flux off, and I played around with just leaving it alone and going on welding, and I don't seem to be any advantage of wiping the flux off. You would think that you would have to clean the flux off every time you start welding again, but I went and turned around and I did some welding and I grinded it off and it doesn't seem to affect it. So I'm just going to leave it alone with the flux on it, and I'm just going to go ahead and I'm going to run a little bead on it, let it cool down a bit. Now, I am not letting that cool now, but it's my own fault. I'm just trying to weld the slider stuff. I'm totally amazed at how nice it lies down and the penetration that it gets. I've never used this before. It's my first time using flux. What I want to do here now, I want to experiment with it a bit more and see what it's all about. Because a lot of you have asked me about it, and I had an understanding from listening to other people and what I've seen that you should always use gas wire. It is hotter. It's a different weld, I can guarantee you that. Now there's what it looks like before I even bother to clean it up or whatnot. So I'm going to go ahead, I'm going to clean that up All I'm going to use is just a simple little brush, steel brush there. Let's extend that, so all the flux is off it. It's a very low weld. I'm totally amazed with that. But this is what gets me. Okay, here's the weld that I just did. Okay, there's the penetration. Totally amazed with it. You know, a lot of people have a lot of negative things saying about it. Now, there is a high heat to it. Now, I put a lot of heat into that. So, I'm going to turn around, I'm going to add that to my list on the thing over there and do a bead on it with that setting. And then what I'm going to do is I'm going to do a, up here in this panel here, I'm going to cut a hole in this, and I'm going to do the cutting butt, and I'm going to use the flux core to do it. So far I got the 030, and I got that welded on, and then I turn around, I've done this here. All I've been doing here, again I'll repeat it, is I'm setting up the welder to weld this light stuff here that I got done here. And then when I'm doing whatever the settings are, I just run a little bead along here just to see what it looks like. Now most people will be saying, well Tony, why don't you just run a bead? I do all pulse welding, and I gotta simulate the same thing as if I'm doing on the metal. If I just run a straight bead on it, it's not the same. You cannot do that on a sheet metal. So I went ahead then and I turned around and done a pulse style welding on it, like I've done with everything else. So there it is. I haven't bothered to clean it all up. It's the Flux 030, and you can see it compared to the other two. So I'll just clean that up there now and show you what it looks like. And there you have it. It's a narrower weld, as you can see, and it is a higher weld, or a high weld. It's about the same, a little less than, yeah, it's a bit in between this one and this one, the height of it. But there's an awful lot of splatter, So there's a lot of cleanup they had to be doing after the fact. As you can see, the splatter that's all around this here, and then you look up here. There's very little on that there, and that's using CO2. If you had used an argon mix, you'd have less of that again. But what I'm going to do now, I'm going to get that done. I'm going to go ahead now, and I'm going to do a little cut and butt test on it. See what it's like. Now I went ahead. This is the 22 gauge. All I done is I took a square, I cut it off the bottom of it. I'm just going to lay that right over the top of that there. I'm going to tack weld that on there, and I'm going to do the cut and butt all the way around it, and tack weld it on, and then I'm going to weld it all the way around. I'm going to grind and dress it. The reason why I just want to run this through the process to see about how much trouble I'm going to have, because doing what I'm doing, I'm really still not getting the full effect of any issues that I'm going to have. Like I've done this here many times doing these type of panels with the regular 023 wire with gas, but I've never done it with flux core. So like a lot of fellas are asking, can you do it with flux core? Well, we're going to find out now if I can do it with flux core. And that's the whole point of anybody else, but that's the biggest thing I'm going to find out here now. So I'm going to go ahead now and start tacking this on and get this all done. Now this is a very small patch for doing a cut and butt on, so I got to be very careful with heat, because like I'm not that far away every time I weld it. So I'm going to be doing a lot of cooling. It's going to take me a little while to do it. So I'm going to try to see if I can do a really good job with this now with just using flux core. Now right off the bat, the first thing I'm noticing is when I first hits the arc, there's a hesitation for it and get a good penetration. I'm going to try cleaning the tip off, snipping the end off it, and trying to spot weld on that there before it does anything else. Because you usually got a dirty wire on the end of it, so if I cut this off, will it make a difference? Let's start with a fresh piece, right? So, try that. To me, the process is the same. It doesn't make a difference if I do it or not. So, I'm going to go ahead and start cutting it. Starting to see major heat transfer. A lot more heat coming from this. When you start using a product or using something and actually using it for a job at hand, you start to see things. Like, to me, I looked at that when I was welding. It seemed like it was a really good weld. Everything was going on. I'm seeing a lot of things going on here now. The gap is, if it's in either one at all, it's very hard to weld it. The heat in it is unreal when you hit it with the arc, how much heat transfer you get. So, like, if you're welding up panels with this stuff, and putting in the car and you're not getting it flat and straight like you see on the videos that I do, that's one of the main reasons why. This flux core is very, very tricky to use. The smallest you can get is 030, the wire size, so it needs to be hotter. And it just seems like it's a hard thing to work with. It's not the same just running a bead on it, so I'm going to continue on, see how far I can get with this. Make this look presentable looking. See if I can make a patch out of it. Seems to be harder to break clear on the back side. I usually don't have no troubles with this. This usually always falls off. But there's that much heat going through it. It's actually welding the piece on. Just trying to get it apart. There we go. Now that I got it apart, straighten it up. I got the piece taken out. Had a lot of troubles with getting it out. So now I'm going to go ahead and start tacking that around there and see if I can weld it up. I had to move it out here in the end because it's going to weld at the top of the table from what I can see. Okay, this is where I'm to now. As you can see here now, I'm burning holes in places. I just turned down the welder even more. I'm turned way down to here now. I'm getting down to the lower settings. I haven't touched my wire speed yet. I left that alone. I'm just trying to control the heat. And this here to bring it down lower so I can weld it. So I'm going to go ahead now. I'm going to get a bit of warpage on this because it's just a flat panel and it's open, and of course it is slightly metal. But I'm just going through the process here now just to see how much trouble I'm having with this. Now you've seen me do a lot of this work and you don't see me with a lot of this. I get it at times, but this is like crazy, the amount of blow through you're getting through on this here. So like, if you're using flux core and you're getting this type of thing on the go, it's not you, okay? Yeah, well, it is you, but still in all, this flux core to me is a lot harder to work with sheet metal than it is anything else. Like this here, between this here and where's he do? This one here. This welding here, that's the 023 with the gas, and this welding here, it's night and day. I can tell you that right now. I've used this a lot. I've done this technique a lot. You've seen me do many videos. I'm having a lot of troubles here with this. Welding this with the flux core, with the 030 wire. You can't get smaller wire, and I'm turning it right down to heat settings. I hear people talking about it. So, you know, this is the reason why I'm doing this experiment. I wanted to show you guys that, you know, I got 30 years out of experience, and I'm still having troubles getting all this welded up with using flux core. And so I'm going to go ahead now and I'm going to start continue on welding this up and see if I can get it welded up. Okay, what I'm noticing here, if you go back and listen to it again, there's a hesitation when you first strike the arc to when you get penetration. Now there's a timeline between when you first strike the arc and the penetration hits, and that time you're adding heat to it. I'm not getting, like, you're going to hear it go zit zit zzz, zit zit zzz. When it does that, it seems like it's getting too much heat into it in order to make the arc. And by then you're burning up the metal. So I just thought I've had to lower the wire speed now as well, and I'm still having issues with it, trying to get it welding. Now some guys have been at this a long time and using it for body work. You can probably overlap welds with this without an issue. But I do a lot of cut and butt, and I wanted to experiment with this here just in butt welding alone. You know, it's probably great for patching up an old car or something, slap a piece of tin over it and tack weld it on and have a bit of filler over it. Fantastic for that. But if you're doing any amount of restoration work or you want to do really nice work, it's a big undertaking to use flux core in this concept. Just listen to the weld. You can see me there trying to get it to heat, and you got to leave it there for a little bit just for it to get the heat going, and then by then you got so much heat into it you're burning holes in it. Now you can see here now I've after welded it up on this side here, and a few times after blowing through. The biggest thing that happens when you go blows through, the first thing you're going to want to do is to keep going and put more heat into it to try to fill in that hole. You got to stop, you got to leave it alone. You got to go on, weld something else and come back to it again later. And I'm constantly blowing through holes. All I'm trying to do here now is just, I'm not even going to bother to try to finish this whole patch because it's just way too messy, is I'm just trying to finish this much of the patch so I can dress this up to see what it all looks like. You know, it's not easy, right? It's not an easy thing to work with, especially on thin metals. And a lot of you guys are using, like, you know, a lot of later model vehicles and that. And then you go out and you buy a cheap little welder and you put a roll of flux in it, you start welding and wonder why you're such a bad welder. Well, you know, it's not always you. This flux core is designed for structural steel, okay? You can do wonderful jobs with this here, put beautiful beads on it, and like welding 2 pieces of plate together. It's very, very tricky to use on body panels, okay? I'm gonna go ahead now and I'm gonna continue on and try to get this all welded up so I can get it to here, and then I'm gonna grind it off, see what the penetration's like on the other side and whatnot, and grind all this up, see what it looks like. And as you can see here, if you look at it, there's a lot of warpage in that. Now a lot of that got to do with it just being laid out as a small panel and it's got no structure built around it and whatnot. But there is an abundance more heat in this than I can see, than I'm used to, right? And like you can see me trying to weld it up. It's very, very frustrating to try to weld something up and then you blow another hole, and then you go to weld up that hole and you blow another hole. You know, so it's very, very, very frustrating. So I'm not going to weld no more of this. I'm going to go ahead now and grind up this section here and see what it looks like. You do get really good penetration with it. That is, you know, that's one good quality about it. You know, you're getting the penetration that you're after. So you got no worries about it letting go. But, you know, you're getting that much heat. This is what you got going on. Now, a lot of that is, you've probably seen me hitting it twice here and there. Like anybody else, I'm getting a little bit frustrated with it because it's not welding together for me. Now, like, you know, there's pretty big gaps there. It's not as tight as fit as I'd like it, but I run into that problem all the time. It's not always tight, and I always manage to get it welded up with the MIG welder. And so, you know, this type of thing. I played with this earlier, and I thought it was wonderful stuff, but now that I'm actually doing a panel with it, it's totally different, right? Like, when you start getting into welding, the advice from a certified welder, guy, you know, an iron worker, that if you're planning on doing body panels, restoring an old car, he's not the guy that you should go to get advice from, because he's using structural steel. Unless he's a guy that does it himself and does auto body, and you know, a fellow like that would probably be a good fellow to go to. But every time, like when you see welding online, how to MIG weld and, you know, how to butt weld and all this type of stuff, they're always using heavy steels to do it. It has nothing to do with body work. This is a totally different puppy, right? So now I'm going to go ahead now and grind that up and see what it looks like. Now I went ahead and I grinded it all off. It grinds much the same way. There's a few imperfections in it, nothing serious, but the biggest thing I'm finding is that right down through the welds too, it pulls really, really hard. Like, it's really low. If you look across it, you can see how much is pulled down, and that's because of the amount of heat that's in it. I don't like the whole idea of when you strike it, it almost takes 3 attempts for it to actually get penetration. That arc is very unpredictable. That's probably the best thing to say about it. And you want heat, but you don't need too much. And the flux core applies too much heat. Now I got a couple of spots here where there's holes. I'm going to try to weld them up there now. You can actually see that pulling away from it, but you can hear the way it arced that time. So you'd want to heat that again. That worked out all right. You can use it, but it's hard work. If you're new at this and you're just picking it up as a hobby, I do not recommend using that. Now people are going to say, yeah, well Tony, you know, you're the first time using flux core. Hang on, no. Now I just turned the welder up. I never even tried to put any settings around it. I got 2 pieces of 1/8 plate here now. try my hand at flux core and glue these together. I'll leave it full wire speed. Try this. And that is a flux core weld on heavier steel. Bring it off there. That's a pretty good weld. So it's not like I don't know how to weld. This is what flux core is designed for. That's a really nice weld for welding plate and everything together. But you can see and can hear how nice that welded. And this is what you always see. And like you see, if I can lay down beads like that, it's great. But then you take that and apply it to this. And this is what you come up with. So this here and this here is totally different. So using knowledge of this here to weld this here, it's not a good idea. Now I do have this roll of 035, which is flux core. It's a bigger roll again, or it's a heavier wire again. I got everything there. I'm really not going to go through the motions of that, because I know for a fact that that'll never weld that, okay? I'm having a hard enough time trying to weld that with the 30. So you can only imagine what it's going to be like if try to do it with 035. So, you know, all it's going to end up happening is if you look at it here, you can see the difference from here to here. It's a bigger weld. So the same thing is going to happen here. There's going to be more heat, the whole 9 yards, right? So like, you know, that's the 023, which is 6 millimeter, or 0.6 millimeters. And then you got the 0.30. It's a bigger, thicker weld. That's 0.8 millimeters, right? And then of course that's the flux core there, which is, there's a lot of splatter. It's a narrower weld. As you can see up here, it's a much hotter weld. Just as it takes a trick to it to get it to work, right? But like I said many times, fellas talk about wire sizes. What size wire do you use, okay? Let's go over some of the things now, the characteristics of it. I always use 023 for doing auto body work, sheet metal work, or anything like that. Why? Because it's a smaller a wire and it lays down, okay? This wire here, if you look at the two of them, one is a lot harder than the other, okay? That's what ends up happening when you use this larger wire. Fellas say, well, I'll just use the 030. What you're going to end up happening then is you're going to need some grinding to clean that up. So here we have it now. We got the 023 or a 6 millimeter stuff, and this is the weld here. That's what it looks like. It's small. The heat range is small, right? It gets good penetration, right, through the back side. There don't seem to be a lot of warpage around the area. Over here, you got the 030 with the gas, and you can see here there's a lot of heat around it. There's a lot more heat on the top side, because like I said earlier, I went and ran the bead down through it. But if you just look at this top one compared to this top one, there's a lot more heat. Now I think this here would react the same way using the 030 with the gas. Like as you can see down here, I was blowing holes in it. Over here, I never had no troubles with blowing holes we're talking about, right? So I was getting all the penetration, and this is only 22 gauge metal. And then of course, I done this here test, and it looked good. It had really good penetration and everything, and I just found it. And the reason why I figure it's that there is like that is a really tight fit. So the key to using this stuff, my firm belief is you got to have an extremely tight fit. So I wouldn't recommend doing the cotton butt using flux core, because there's always a gap up there. You'd almost have to file the fit to use flux core. And then the timeline it takes for the heat range to use it, it's so hot. It runs a problem. I do not recommend using flux core for auto body metal work. For the simple fact, it has too much heat in it. It's a dirtier weld, as you can see up here. You can see there's a lot of material and everything on that. You can feel it there. Run my finger across it. There's a lot of dirty welds. And it's just the whole point of trying to control it, trying to control your heat. It's cheaper, yes, but without a doubt. Get yourself set up again. But if you're going to do body work with flux core, forget about doing like butt welding and stuff like that. Just turn around and just do an old lap weld like that and weld it down across there. That's my advice to you. Because doing this here, the cut and butt and butt welding and everything with flux core and sheet metal, it is tricky. So I'm hoping this here clears up a lot of things. If you have any questions, you know, if you want me to say, well, why don't you try this or do this experiment here, and you know, this type of thing. Like, you got to realize too, this is my first time using flux core. I've been in the trade 30 years and I can't even remember using it. I was talking to one of my buddies and he says the same thing. He don't even remember using flux core. He can probably go back 35, 40 years ago and he thinks he might have used it, but he's not quite sure. So it's not something that I use a lot. But do I know how to weld it? Yes, I can use it. I can weld with it, right? But it's heavier gauge steel. This stuff is different. Right? So, you know, my advice to anybody that's going at sheet metal, okay, doing it as a hobby, first thing you got to figure out is what kind of welder you're going to get. I would get a welder that took gas, and I would get a bottle of CO2 or argon and with 0.23 or 0.6 millimeter MIG wire to do your metal work. That's where you should start. Because the problem you're going to have if you're teaching yourself how to weld, if you're going to start here, you're going to frustrate yourself. You should start here, because this is like the difference between night and day with trying to do two panels. You guys have seen me do a lot of this work, and you can see the mess I got made of this, okay? Now you can only imagine, like, I got 30 years experience in this. You can only imagine somebody just picking up a welder for the first time and then trying to weld it, trying to set up his welder, trying to do it all, and then try to do the same work. It won't be easy, right? So I'm hoping this was all helpful for everybody. I hope the tips were good, and until next time.